This is the demo for the individual assignment of the IoT course 2022. In this demo I will show my project automatic greenhouse, but due to the nature of what the system measures and to make the demo more concise, I will manually alter the measurements. The goal is to create a system that measures the main aspects that affect a plant and depending on those values act accordingly. The first functionality is about temperature. Indeed, the system turns on a heating bulb when the temperature sensed is lower than a threshold, and turn it off when it's higher than the threshold. So, as you will see, heating up the sensor makes the relay switch off, turning off the light bulb. Now that the temperature is higher than the threshold, the relay switch off. The user can interact with the system using these buttons. In particular, relay is always on keeps the relay active even at high temperatures. As you can see, now the bulb is on even if the temperature is high. I can bring back the system to automatic using the relay automatic button. On the web interface it's possible to see the aggregate values for both temperature and humidity. In particular, we have average, max, mean and variation. These measurements gets updated every time a new value is received. As you can see, all the plots in the page are updated as soon as a new value arrives, and these values are shown in the info box. Now that the system has turned on again the light bulb, I can show you the last between these three buttons, which is relay always off, that keeps the relay off even if it should be on. The second functionality is about soil moisture. Indeed, the system opens the water using the servo motor when the moisture level is under a certain threshold and close it when it's higher than a certain level. As you can see in this demo, now the servo is closed, which means the water is closed. Now I will force the opening of the servo. Now the servo motor is open and it will close only when the sensed value is in the specified range. Now that the servo is closed, I can show that we can interact with this actuator from the web interface. In particular, we have the servo always on that keeps the servo open even if it shouldn't be, and the servo always off that does the opposite, meaning keeps the servo closed even if it should be open. You can see on the plot that we are roughly on the same situation as before when the servo opened, but in this case it does not open. We can also set it back to automatic using the servo automatic button. Like for temperature and humidity, also in this case we have the aggregated values, meaning average, max, mean, and variation in the last hour. Updated like the plot at every new value.